All right, so I was given an integral, and this integral, we could solve it in two ways. One is which that we could multiply by a form of one, and another is which that we could use substitution. And this particular use substitution has been given, so the question was us to use this substitution to solve this integral. Now the resulting integral will be, well, only differ by a constant, but later on I'll be showing using decimals on like how much of the difference is it. Anyway, so we're given that the integral of 1 over 1 plus sine of x. And the first solution that I'll be showing is by using multiplying by a form of 1. So the function here, I'll be multiplying it by the conjugate of the denominator. So 1 over 1 plus sine of x times with 1 minus sine of x divided by 1 minus sine of x. Okay, now from here we could expand it. Now we will obtain 1 minus sine of x divided by 1 minus sine square of x dx. And now we know that the denominator is from a trig identity, which is the cosine square x plus the sine square x is equal to 1. And we can express this in terms of we could express cosine square of x in terms of sine square of x. Therefore, we will have cosine of square x is equal to 1 minus sine square of x. Now from here, we can substitute, express it for the denominator in cosine of x. Therefore, we will obtain 1 minus sine of x divided by the cosine of square x dx. Now from here, we can separate the integrand. And by separating it, we obtain two terms, which is 1 over cosine of square x minus sine x over cosine square x dx. Now we could express it again in another form. Now we know that the reciprocal of cosine, the reciprocal of a second x is 1 over cosine of x. Okay, and then the second term, which is sine x over cosine square x, we could separate it to become sine of x divided by cosine of x times with 1 over cosine of x. Okay, then by remembering the other trick, like the trick expressions, which is second of x and then cotangent of x, secant of x and tangent of x, we could evaluate the integral. Okay, so I'll be expressing it first. So the first term will be the second square of x minus the tangent of x dx. Tangent x second x. Now you'll be recognizing this integral. You can evaluate very easily. It's because that second square x, when you integrate that, you obtain tangent of x. And then tangent of x, second of x, will be second of x. So it's very nice. Let's see. Okay. So this is one of the solutions. Okay, by multiplying by a form of 1, which is I multiply by the conjugate of the denominator. And now the second method, well, the second solution is that we use substitution, but this is a very specific one. We switch that. Let me first write that the integral. So 1 divided by 1 minus sine of x dx. And here we evaluate the integral by using the use substitution method. Now, it's very weird to use this substitution because it's a half angle. Okay, so the given substitution that they want us to use is the tangent of x over 2. Alright, so the way we want to solve this is my friend told me that we have to build a right angle triangle first. So how do we do that? First we have to find tangent of x. And we know one of the identities for tangent of x is that we could express it in half angles. So this will be 2 times the tangent of x over 2 divided by 1 minus the tangent square x over 2. And we know that tangent x over 2 is u, so we could create this as 2u over 1 minus u squared. Alright, so from here, we realized that we could build a right angle triangle, and from there we could express it, could find that could express sin of x and cosine of x in terms of u. So that's the cool thing about this one. So yeah, let's build a triangle first. Okay, then here will be the right angle, and so here will be my angle x. So by using the acronym SOHCAHTOA, yeah, TOA will be opposite and adjacent. So the opposite will be 2u, and the adjacent will be 1 minus u squared. And then the hypotenuse will be 1 plus u squared. Yeah, is it 1 plus u squared? Sorry, if I recall back, it would be u squared plus 1. Oh yeah, so with the way we argue, when we find the hypotenuse, so 2u, by using the Pythagorean theorem, yeah, plus 1 minus u square, the square root, right? We evaluate this, we will obtain the following, which is 2u square. Sorry, it's not 2u square, it's u to the power 4 plus 2u square plus 1. And we can express this in terms of like binomial term. So it will be u squared plus 1 to the power 2. Now, since u squared plus 1 will always be positive no matter what, we can ignore the absolute value that has been created here. Therefore, we will obtain u squared plus 1. Right. Now, the hypotenuse will be u squared plus 1. And from there, we could build our, well, not build, I mean finding our values for cosine and sine of x. But first, let me take the derivative of u here. So the derivative, the derivative of u respect of x, no, sorry, this equation here, respect of x, will be du is equal to the tangent of x over 2 will be the second square x over, sorry, it's not second x, it will be x over 2 over 2. Now, you know what, I'm going to create down here so that it will not interfere with my drawing. So let me go down here. The derivative of it will be in respect of x, second square x over 2 over 2. Now the idea is that we do know the identities of trig, and we could express it in those terms. Therefore, this, we could evaluate this as 1 over 2 cosine of square x over 2. And now, if you call for cosine of x, we could express it for half angles, which is 2 cosine of square x over 2 minus 1. And when we express 2 cosine square x over 2 in terms of cosine of x, this will obtain the following, which is cosine of x plus 1. Okay? And now, by referring back to here, we can express this as du is equal to 1 over cosine of x plus 1 dx. By multiplying both sides with the denominator, you obtain cosine of x plus 1 du is equal to dx. It will be important a second later. But yeah, let me just put it back in the integral here. This is very long. I'm put it here. Okay, I'm gonna put it like this. Right, so this could be evaluated as 1 plus cosine of x over 1 minus sine of x du. So cosine of x and sine of x has to be expressed in terms of u. Therefore, by referring back to our drawing, our right angle triangle here, we can express sine of x by using the acronym that we mentioned, SOHCAHTOA. So means that the opposite divided by the hypotenuse. Therefore, it will be 2u divided by u squared plus 1. And then the cosine of x by using the acronym adjacent hypotenuse, you have 1 minus u squared over u squared plus 1. So all the terms, the respective terms, sine of x and cosine of x, we could express it in terms of u. Therefore, from here, you have 1 plus 1 minus u squared divided by u squared plus 1 divided by the term 1 minus, and then sine of x will be 2u, u squared plus 1 du. Now it looks better, right? Now from here, let us try and simplify it. So the numerator and the denominator, let me combine those two terms, become a single term. So this, we will express the denominator will be u squared plus 1 plus 1 minus u squared will be 2 over u squared plus 1, then divided by with u squared plus 1 minus 2u divided by u squared plus 1. And now from here, we could like simplify it. Then we will obtain the following: 2 over u squared minus 2u plus 1 du. Now, u squared minus 2u plus 1, we could factor it to become this: 2 over u minus 1 squared du. And by using the power rule, we could evaluate this integral very easily. So this will have negative 2 over u minus 1 plus c. And now, for u, when you go back here, this will be our expression. Therefore, it will be negative 2 over the tangent of x over 2 minus 1 plus c. So that's our resulting integral by using the substitution method. So let me show you graphically on why both of them are the same but differ by a constant, right? So let me just find the decimals. Okay. So it's really important to know other solutions on an integral, sorry. So the first resulting integral is that we use the multiplying by form of 1, and that is where is it? Tangent of x, and then we have minus secant of x, right? So that's it. Okay, that's the graph, the graph that we obtain. Now let's compare it to the second solution we obtain, negative 2 over tangent, but the half angle tangent, and then, oops. All right, this is difficult. Okay, plus 1. Okay, so it doesn't seem much that they are alike, but when we shift the red graph downwards, I suppose, when we shift it down, they overlap, means that they are the same. So minus 1, therefore, there you go. Both of them are the same graphs. Okay. So when it's overlapping for, it's basically the same thing. Okay. Just differ by a constant. So no worries if your answer is very different. But just check again and see whether they are equivalent. Sometimes the scheme answers show only one answer, but there are other methods to solve an integral, so you don't have to worry much about it. As long as you didn't create any careless mistakes, then you should be fine. Okay. Alright, so that is all for me. Thank you very much for watching, and I'll see you again later.